Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X published on March 4th, 2026, just 4 days ago. It introduces a novel repository-level benchmark that shifts the evaluation of large language model agents from simple, one-shot bug fixes toward dynamic, long-term code maintainability, which is crucial since maintenance accounts for 60 to 80% of software lifecycle costs. The paper is titled SWE-CI, Evaluating Agent Capabilities in Maintaining Codebases via Continuous Integration. And as we will dive into later, the experiments reveal some really striking differences in how various models manage accumulating technical debt. Well, Figure 1 illustrates this shift by comparing the traditional testing approach with the new continuous integration loop. The left side shows the standard snapshot-based evaluation, where an agent makes one isolated update to the codebase based on a single requirement. In contrast, the right side maps out the evolution-based evaluation, introduced by the software engineering continuous integration benchmark. Here, the codebase undergoes multiple consecutive updates driven by an ongoing sequence of requirements. This continuous cycle forces the agent to carefully manage early design choices, because brittle fixes can easily cause regressions as the software evolves. So, after the previous figure outlined the evaluation shift, Figure 2 breaks down how the benchmark tasks are actually curated. The process begins in Step 1 by filtering real-world GitHub repositories, selecting those with at least 3 years of maintenance and 500 stars. Next, Step 2 extracts commit spans from the main branch, which helps identify long sequences with stable dependencies. Finally, Steps 3 and 4 handle the complex setup of Docker environments and case filtering, ensuring that each task captures a substantial evolutionary history with a clear test gap. Alright. Figure 3 details the evaluation protocol, which uses an architect-programmer dual-agent workflow to simulate a professional continuous integration environment. First, on the right, the architect agent analyzes test failures and issues high-level design requirements. Then, on the left, the programmer agent uses those requirements, working to comprehend the expected output, plan a solution, and update the codebase. Finally, the bottom section illustrates the testing phase, where the updated code is evaluated against expected outcomes, generating a report that feeds right back into the architect's analysis for the next loop. Okay, after Figure 3 outlined the evaluation protocol, Figure 4 plots the performance of 18 state-of-the-art models over time. The horizontal axis tracks the release date, while the vertical axis measures the EVO score, which is the benchmark's custom metric that rewards long-term maintainability and penalizes regressions. The upward lines reveal a rapid advancement in continuous integration capabilities, particularly for models released in late 2025 and early 2026. The Claude Opus series clearly leads the pack at the top right, and models like GLM5 and QN 3.5 Plus also demonstrate steep improvements in their most recent versions. Well, Figure 6 focuses on a critical challenge, ranking the models by their zero regression rate. This metric measures the proportion of tasks completed without breaking previously passing tests. Looking at the top and middle bars, we see that almost all models struggle here, falling below a rate of 0.25. However, the Claude Opus series breaks away at the bottom, with version 4.6 reaching 0.76. This stark contrast shows that while models can successfully write new code, maintaining stability over continuous updates remains a major hurdle. While the previous figure highlighted the widespread struggle with regressions, Figure 5 now maps how the model's EVO score rankings shift as the weighting factor, gamma, increases. The vertical axis tracks gamma from 0.8 down to 1.2, where values over 1 place heavier emphasis on long-term codebase maintenance. As the lines crisscross, they reveal distinct provider philosophies. Some models shift toward the right, improving their standing when feature evolution is weighted more heavily, while others drift to the left and drop in rank, illustrating the trade-off between immediate functional gains and sustainable design choices. Alright, wrapping up, the main takeaway is that while large language models are great at one-off fixes, sustaining code quality over time remains a major hurdle. This new benchmark finally provides a realistic way to evaluate how well agents handle long-term software maintenance. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.